Hello, it's Keith here, and this is lesson 21 of the simple series of my 650 assembly programming tutorials. Now, in the tutorials at the moment, we're looking at sprite clipping, and what this is where we're drawing a bitmap sprite to the screen, like the one you can see here, and we're dealing with the effect of clipping the sprite when it partially goes off the screen. So you can see we've got our Chibico example that we used in the simple series bitmap example, but the bitmap example has been upgraded, and it now allows the sprite to be clipped so that it can be partially off the screen, as you can see here. And you can see that this will work in all of the directions of the screen, so top, bottom, left, right. So this is the example we're looking at today. Unfortunately, it's not really a very simple example at all. There's a lot of code involved in this, but I'm including it in the simple series because the simple series concept was that each example is a self-contained assembly file without really any other files being linked in, and it does a single task, and the intention is that you can take this and build on it and make your own game. And those things are still true of this example, that it's a simple example of if you need to do sprite clipping, this is about the most basic way you can do it. Now, I'm not saying that the example I've got here is by any means the best or anything. It's a perfectly functional one. It's the best one I've written and the best one I can create, but I'm not saying it's the way you should definitely do it. If you can think of a better way, if you've seen a better example out there, please go ahead and use that. The other thing I would say is that if possible, if you're just starting out programming, I'd suggest you make a game that doesn't require sprite clipping because it is quite complex and quite slow. That said, let's go over to the example and let's take a look at our code today. So here is our code file. So we're looking at the file C64 bitmap clipping here. This is the example code, and it's based on the original one within the simple series, the bitmap example, which showed a bitmap to the screen but didn't allow for it to go off the screen. So you can see that we've got the code here. We're defining some zero-page entries that we use for temporary variables here. So the letters don't particularly have a meaning. We'll just see them being used in various places. The pairs are made up of two 8-bit parts. These mimic the Z80 registers, but as I say, the letters don't have a particular meaning from the point of view of this code. You will see the meaning described in the code itself. So the most important thing we need to discuss first is the coordinate system that this uses. This uses something known as logical coordinates. Now this defines a screen area where the center visible screen area is the part that is drawn to the screen, and then there is an invisible area outside of that. And the important thing is that the logical coordinates of the width of the area and the height of the area do not go over a single byte, and the reason for that is we're working on 8-bit systems. They work very well in bytes, but they're a bit slow in 16 bits. So it's more logical for us to use a coordinate system that allows us to work within 8-bit bytes rather than having to extend out to 16 bits. Anyway, let's go over and have a quick look at the screenshot that describes the logical coordinates. Okay, so this is the coordinate system that we use in my tutorials. Essentially what we use is a coordinate system which works on 2 pixels are equal to 1 logical unit. Our typical screen is 256 by 192, so this gives us a logical size of 128 by 96. Now we put this in the center of the screen, and this is to allow us to crop a sprite that's partially on the screen. Now you can see an imaginary sprite here. This is our Chibico that we're imagining being drawn at this position here. And you can see that the area that's within the visible area of the logical range will be drawn to the screen, and this darkened area will not be included. Now this is showing the typical size of 128 by 96, and that's assuming that the system we're working on can be reconfigured to work at 256 by 192. But the Commodore 64 screen is always 320 by 200, so we're using a logical size on this system of 160 by 100. So these coordinates aren't actually right for today's example, but the concept still stands. Now the coordinates we're actually using in today's example, the screen is going to be 160 logical units wide and 100 logical units tall, and we're going to have a border of 48 logical invisible units on the left and right and 78 logical units at the top and the bottom. So that's to allow our cropping. So for our sprite to be visible in the top left corner, we set our sprite's position to the minimum x and minimum y, so 48, 78, and you'll actually see that being done just here. So this is the initialization there. Now the input routines and the movement routines that you can see on screen here are basically the same as they were in the simple series, and we're not going to cover them. So if you need to know how that kind of thing works, then I'd suggest you look at the bitmap example. And as I say, if you're just starting out programming, I would suggest you try and design a simpler game that doesn't need sprites to partially go off the screen. If you look at my YQuest game and my Grime Z80 game, these didn't need a sprite to ever go off the screen. It was never needed any kind of clipping, and so there's plenty of fun little games you can write without having to worry about clipping. Anyway, if you are looking at clipping, then this is what you're going to need to do. So the way my code works is we've got this draw routine here, and we load the address of the source bitmap data into the IY pair of 0-page entries here. So that is the source bitmap data. We then load the width and the height into H and L. Now the width and the height here are 24. Now the sprite is actually 48 by 48 pixels, but as I say, we're working in logical units here, so that's 24 by 24 logical units. We then use the do crop function, which is the calculation routine that calculates how much we need to crop. When this returns, it will set or clear the carry flag. If the carry flag is set, then there's nothing on the screen, so we want to abandon the drawing. If the carry is clear, we want to draw the actual sprite to the screen, which you can see just here. So we're going to start off by looking at the crop routine itself. Now you can see it here, but I think first of all it's important we discuss some of the theory. So if we just go over to the blackboard here, we will discuss some of the concepts of cropping a sprite on these systems. So if I just draw an imaginary screen here, so if we imagine that this is our visible screen, so there we go. And then if I say we've got a sprite here, and our sprite is of course, whatever the shape of the sprite is, it is a logical kind of square. And our sprite will move around the screen as we play our game or whatever, as we move our test example here. But at various points, the sprite will go partially off the screen, of course, and we're going to have to deal with that. Now, the way we will deal with it will depend entirely on where the sprite now is. Let's say the sprite goes off the top of the screen. Well, now what's happened is the height of the sprite has now changed, so we will need to change the sprite's height to this here. We don't want to start drawing here, we will actually want to start to draw at 0, and we will need to skip part of the bitmap data of the sprite because this part of the bitmap data is no longer needed. So that's what we will need to do if we go off the top of the screen. If we go off the bottom of the screen, we'll just need to change the height of the sprite. If we go off the left-hand side of the screen though, there's going to be a few things we're going to want to do. In the way my code works, what we do is we first skip the first part of the first line, and that's so that our drawing routine will start just here. And then at the end of every consecutive line, we're going to need to skip the next line in the bitmap data. So that's what we would do there. And of course, we'd have to change the width of the sprite to just this part here as well. So that's what we do on the left-hand side. On the right-hand side, though, we'd need to change the width of the sprite, of course, because now we're just drawing this part here. But we don't need to skip any of the initial bytes because we're still drawing from the very start of the sprite. But at the end of each line, we're going to need to skip this part here. Now, there are, of course, cases where it goes over both sides of the screen, and we will need to do a combination of these in those cases. And fun fact, the old Chibi Akuma's game didn't do it right. It couldn't handle those corner cases. My code wasn't good enough. I really struggled to write the cropping routine, and that's why I say I'm pretty sure this isn't the best way of doing it. This is just the best way I can do it. I'm not the best coder in the world, funnily enough. I'm just an average person. So this example is the best I've ever made, but it's not the best in the world, I'm sure. But anyway, we're going to show it to you today, and if it's any use to you, go ahead and use it. Okay, so here is the start of our cropping code. Now at the start here you can see we're loading the Y register with 0, and we will use that in various places to quickly zero various values. Now sprite hclip is used in that case where our sprite has gone off the right hand side of the screen and we need to partially clip stuff before the start of the next line. So that's what that's used for. We're zeroing it here because we're going to assume the sprite is entirely on the screen, but maybe it's not. And the D/E pair here are used as temporary variables during the various stages. So you'll see those appear here. So first of all, we're going to crop the top of the sprite. So we're going to take the Y position in logical units that we want to draw our sprite to. And what we're going to do is we're going to subtract the minimum Y, which is the top first visible line of the screen in logical units. Now, if this has caused an overflow, then that means that our sprite is partially off the top of the screen. So maybe our sprite is somewhere like this, it's partially off the top of the screen. So we're going to have to crop it. So this will have caused the coordinate to go negative, and the negative coordinate is the amount we want to actually remove. So what we're doing here is we're flipping it back to a positive number, and then we're comparing it to the height of the sprite, because if it's actually the entire height of the sprite, then the sprite is completely off the screen, in which case we're jumping to do crop all off screen. And this is a routine that will set the carry and return. So that is just telling the calling routine, hey, there's nothing to draw, turn, give up, just stop drawing. If that's not the case, then we've calculated the amount we need to remove from the top of the sprite. So we're storing that new amount into ZE, and we are now zeroing the accumulator, which we're going to store into C, because whether the sprite needed cropping or not, after subtracting the minimum Y, we've now got a little step closer to calculating the physical line from the logical unit that we want to start drawing our sprite at. So we're storing that in ZC here. Okay, so now we've done the top coordinate, we're now going to look at the bottom one. So we're now adding the height of the sprite, and we're now going to compare that to the last visible line in logical units of the screen here. And then what we're going to do is, if that is not over the bottom of the screen, then we don't need to do any cropping. But if it is, then again we check if the amount we want to crop is the entire height of the sprite, and if it is, we give up. But if it's not, we're going to store that into ZD. So ZD is the amount to crop from the bottom, and ZE is the amount to crop from the top. So we've now got the height cropping required. So what we do next is we're going to take those two, add them together, and see if we need to do any cropping at all. And if we don't, we're just going to skip. Otherwise, what we're going to do is we're going to combine these together, subtract them from the height, and store the new height. And so that has adjusted the height of the sprite according to any cropping that's required. What we're going to do next is we're going to deal with the skipping of any lines from the top of the sprite. Because, as I said before, if our sprite is at the top of the screen, then we're going to need to remove this whole area here. So that's what we're going to do next. So we're seeing if any lines need to be removed from the top, and if they do, then we're going to set that as a counter. Now these lines are in logical units, so we need to convert this to the number of bytes per line of our sprite. And so what we're doing here is we're taking the width of the sprite, shifting it once to the left, and we're storing this in E. Now because of the pixels per byte of the C64 screen, this effectively calculates the number of bytes per logical line of the screen, which is 2 physical lines of the screen. And then all we're going to do next is we're going to repeatedly add this to the IY pair, which is our 16-bit address of the source of the sprite data, and that will effectively remove that data from the start of the sprite. Now I'm aware this isn't really the most efficient way of doing a multiplication here, but this routine is only executed once per sprite draw. It's the sprite drawing pixel transferred code that takes all the time, not this calculation. So we don't necessarily need to be ultra efficient here, because it's not the place that's using all the CPU power. Okay, so we've done the vertical cropping, and we're now going to do the same for the horizontal cropping. So we're zeroing D and D again, because they're now going to be our temporary variables for the X coordinates, and we are loading the X position, and we're basically doing the same thing as we did for the Y, subtracting the minimum X, and then seeing if this has caused a negative, and if it has, we're flipping that, and we're comparing that to the width of the sprite. And if the sprite is going to be all off screen, then we give up drawing. Otherwise, this is the amount to crop from the left. We're then zeroing the new X position, because we're drawing at somewhere in the far left, like maybe this here. And then what we're going to do is we're going to do the same for the right. So we're then storing that new X position. We're adding the width, we're comparing that to the width of the logical screen, the visible logical screen, and seeing if we need to do any cropping here. If we do, then we're seeing if we are going to crop off the entire width of the sprite, and if we're not, then we're storing the new amount to crop here. Now whether our sprite is on the far left or on the far right, we're going to need to crop part of it off after each draw, because as I said before, when we are drawing here, then after each line of our sprite, we need to skip the part on over here. And when we are over here, we need to remove this part here. So we're going to need to do that kind of cropping irrespective of which side of the screen we're on. And that's what we're going to do here. So what we're doing here is we are taking those two together, adding them together. And that's what we're doing here. We're taking the amount to crop from the left and the amount to crop from the right, adding them together, and we're storing this in sprite h clip, which we're going to see later in our drawing code. And this is the amount we need to skip after each line. then what we're doing here is we are converting this to the new width of the sprite that we're going to draw to the screen. And then what we're doing is we are calculating the amount to remove from the left hand side of the sprite for the first draw. So we're taking the amount to crop from the left hand side, converting that to a number of bytes and adding that to our source position in IY. This has now converted the IY into the correct starting position, and it's updated everything about our width and the height. And the final thing to do is to convert those logical coordinates into physical ones. So what we're doing here is we're doing some logical shifts here to convert the width and the X position into a byte coordinate, and some arithmetic shifts here to convert the height from a logical number of lines to the physical number of lines, effectively doubling the number of lines here. At this point, of course, we've decided that we're definitely going to draw the sprite, so we're clearing the carry and we're returning. And this has now set us up ready with the information we need to draw our sprite to the screen. Now, the drawing routine itself is actually slightly different from the previous one in the Simple Series. Now, the Simple Series one was working with the Commodore 64 screen in the way that the Commodore 64 screen was defined in memory. Now, if we just have a look at our blackboard here. Now, if we imagine a byte of screen memory like this, the next consecutive 7 bytes will not go across the screen, they'll actually go down. And then the 8th byte will be the next one here. So each consecutive block of pixels of the screen is actually 8 bytes on from the last one. So that would be +8 and that would be +16. That's the layout of the screen. And in our previous example, we actually drew our Chibico character in this format. So the bitmap data went in this kind of format here. That's not going to be very easy for us to crop. So the new code is actually drawing in the way we are probably going to imagine it. So it's going across the screen and then down. And this is much easier for us to calculate the cropping, but it's slower. And that is why when you're doing this kind of cropping things, you're better off avoiding it if you can. And the Chibi Akima's game actually had 2 routines, one that could do cropping and one that couldn't. And this was to allow the speed. If the sprite's entirely on the screen, you don't want to do any clipping. And if it's partially on screen, you want to use a slower clipping routine. And so, as I say, that is something to bear in mind as well. So here is our drawing routine here. Now, we start off by taking the width of our sprite and we're multiplying it by 8. And the reason for that is, as I say, is that after a line, the next 7 bytes in memory are actually below the current one. And so if we want to move across, we're actually going to have to add 8. And so that means that the end position for our byte counter is going to be 8 times the width of the sprite because of that attribute. So that's what we're calculating there. We're then using the get screen pos function here, which is going to calculate the VRAM address that we're going to write to. We're then going to skip over the next section of code because the code here is the get next line routine. This is calculating the next physical position of the destination for our sprite. So the first time we will skip over that. We'll have a look at it in a moment. Here is the start of our code. So we're clearing the carry. We're loading Y with 0. And we are reading bytes from our source IY to our VRAM destination DE. And this is an XOR routine because that's an easy way of removing sprites in this test. So we're loading a byte in from IY offset by X, which is always 0. And then we're writing it to DE offset by Y. Now, here's our first line end. So we're incrementing our bitmap source here. And then we're adding 8 to Y. And the reason we're adding 8 to Y is because we don't want to move 1 byte in VRAM. We want to move 1 horizontal byte, which is 8 bytes on. So we're adding 8 there. And then we're going back up here to sprite next byte, which is just up here. And we're repeating that until we've drawn our horizontal line. Okay, so once we've drawn our line, we're then going to do the next line until we've done all of the lines of the sprite. And so we're jumping to sprite next line. And sprite next line is up here. And this is doing this get next line routine. And so what we're doing here is we're incrementing the VRAM destination by 1. And then we are checking to see if that's within an 8 pixel tall block. And this is again because of that weird VRAM configuration. Now, if you imagine that our screen is made up of 8 pixel tall strips, maybe like this. If you imagine these are each 8 pixels, then going down 1 within one of these strips is just simply adding 1 to the E part of our DE pair. But as soon as we go beyond that strip, we're not just adding one, we're actually going to have to add enough to jump to that second strip, and that's what this code is doing. It's trying to be as efficient as possible, not doing too much extra when not needed. So in most cases we're just doing an inc of ZE and that will be enough, but outside of that 8 pixel strip, that's not enough. We're going to need to do some more. So what we're doing here is we are updating the top byte if required, and then what we're going to do is we're going to effectively add hexadecimal 140, and the reason for this is the screen is 40 bytes wide and each strip is 8 lines tall, and 8 times 40 is hexadecimal 140, and we're going to add that to our DE pair. So we're incrementing the D part here, and then we are adding hexadecimal 40 minus 8 because we have already inked the E part here and actually we didn't necessarily need to, so we're correcting that here. And then we're incrementing the D part here. And that has now calculated the new VRAM destination for drawing. What we're doing next is we're updating the source, because remember, if our sprite is partially off the screen, either on this side or this side, then we're going to need to remove part of that sprite before we do the next draw, and that's what we're doing here. So we're getting the sprite H clip, and if it's not 0, we're adding that to the source bitmap position. And then what we're doing is we're repeating drawing the rest of the sprite, and that is the end of the sprite routine. So as I say, it's a little bit complicated, and this is the best sprite clipping routine I've managed to come up with so far. As I say, far better than the Chibi Akuma's one. As I always say, go to my website, download the source code, and if it's any use to you, you're welcome to use it in any capacity you want, even if it's commercial, if you somehow manage to do that. If you like what you've seen, please like and subscribe. I will be doing more of these clipping tutorials on all of the other systems, and I'm also planning to do some tutorials on tile maps as well, some software tile maps, so hopefully you'll stick around and see that. Anyway, I hope you've enjoyed what you've seen today. Go to the website, get the source code, have a play with it yourself. Thanks for watching today, and goodbye.